Hello students. Today we're going to be talking about Python programming. One of the major goals for this course is to learn how to think as a computer scientist. What I mean by that is we're going to try and learn how to think analytically and numerically. We're going to try and learn how to describe problems and processes and systems in ways that a computer can understand them, and then describe these systems for the computer in such a way that we can get some interesting results. This is probably the most useful skill that you'll have in this class, and problem solving is a key component of this. It's also the ultimate goal of this process. One critical element of programmatic thinking is to develop algorithms. An algorithm is defined as a step-by-step approach that is guaranteed to solve a specific problem. Most often algorithms are related to recipes in the kitchen. You gather up a list of ingredients and then you follow steps in a specific order until you get your result that you're looking for, until you bake a cake. It's important, though, that you do the steps in the correct order. If you try and bake the cake before you mix in the eggs, what you're going to end up with is not what you're looking for. It's not going to be a very good cake. And so we use algorithms to describe the process that we want the computer to go through in order to solve some problem. And we implement these algorithms in a programming language that a computer can understand. This is called a program. The language we'll be using in this course is Python. Python is considered a high-level language, meaning that it's close to a natural language that we communicate in every day. What you'll find as we get started looking through Python code and writing Python code is that you can generally read Python code and understand its meaning fairly easily. There are also low-level languages where this is not true, where you'll see just a string of digits, zeros and ones, or maybe a keyword, JGT 578324916 as an example. And these are much harder to understand. So we generally stick to high-level languages in order to make writing code easier and understanding code easier. Now we can also classify programming languages into interpreted languages or compiled languages. Python is an interpreted language, but some languages are compiled. When we say that Python is interpreted, we mean that when we run our program, it's translated in real time into machine language as the program is running. A compiler, or in a compiled language, alternatively translates code into machine language and save it as an executable. So if you have an exe file on your computer or something similar, that code was written in a compiled language. Python and several other languages like Java or JavaScript combine these processes in what's called a virtual machine, which makes code very portable. It means that you can write your code on one machine and run it on another computer as long as it has the Python virtual machine, or VM. Compiled code is called bytecode, and bytecode is the machine language code. Python's bytecode is run on the virtual machine, which is then translated into whatever the native machine language is. So when we write Python code and run it, the process that's happening is that code is being interpreted in real time to Python bytecode. The Python virtual machine takes that Python bytecode and translates it into what's called an assembly language, which is native to whatever machine you happen to be running on. If you're on Windows, you're probably going to be running the x64 assembly language. If you're on Mac, it'll be some other form. Now when you run the Python VM, you're presented with the Python shell and prompted for input. You can write code at the Python prompt, but it's generally more convenient to write a source code file. You can only input one line at a time at the prompt, whereas in a source code file you can write many lines of code, and you'll quickly find that most programs are more than one line of code long. Python files by convention are saved with the .py file extension. And this is important to note. When you write a program and you save it, if you don't include the .py file extension, you'll lose some features of the Python editor. So it's important to make sure that you save your files properly. A program is a collection of code written to solve some problem or perform some task. The standard format for a program involves three key parts. The first part is gathering data. This is called input. Input can be taken from the user directly from various devices like a mouse or keyboard or a video camera, or it can be read from files. It's then processed. Math and logic is performed on this input and translates it into some new product or new result that we're looking for. These results are then sent back to the user called output. And output most often comes through a computer screen, sometimes through speakers or through a printer or other output devices. Sometimes these elements are combined into conditional execution or repetition. If we need to perform a task several times, we'll use some sort of repetition in order to repeat the code we want to run for every element in a set, for example. Or we'll use conditional execution, where we use formal logic to describe certain conditions under which we follow one code path, and then other conditions under which we follow another code path. Every single computer program you use is made of these smaller parts. These are the fundamental parts of any computer program, and we'll be talking about how we use them today and throughout this course. Now, programming is a very complex process, and people make mistakes. In fact, mistakes in programming are incredibly common. Mistakes in programming are called bugs, and this goes back to the 1950s, when computers were made of walls and walls of vacuum tubes. And a group of researchers had programmed a program into the computer, but it wasn't working, and they couldn't figure out why. They double-checked all their code, and it was correct. They double-checked all their variables, all their logic, and everything was correct. And so they started looking at the machine, and they started pulling out these vacuum tubes to check each one individually and make sure it was working. Well, one of the researchers pulled out a vacuum tube and found a moth had flown into the socket before the vacuum tube had been plugged in, and it was causing a short that was preventing the program from completing. And so ever since that day, when a program doesn't run correctly, we call it a bug. Now, there are three main kinds of errors that occur in programs. There are syntax errors, runtime errors, and semantic errors. Syntax refers to the form of a language or a computer program. In English, we say that, for example, all sentences must begin with a capital letter and end with either a period, a question mark, or an exclamation point. These are the rules that create the structure for the language. Similarly, computer programs must follow rules about their structure. And when you don't follow these rules, syntax errors occur. Now, syntax errors prevent the program from being run. If you're using the idle IDE that comes with Python, when you try and run your program and you encounter a syntax error, you'll be prompted with a message that says a syntax error has been found, and it will actually highlight the section of code that it thinks the syntax error is in, where it can't understand what's being typed in. The second kind of error is a runtime error. Runtime errors don't appear until a program is executed. They occur while the program is running. Runtime errors occur when a program is given an instruction that it's not capable of carrying out, or when it doesn't understand what to do with it. So, for example, if you were to say 5 divided by 0, well, division by 0 is impossible. It doesn't work. But there's nothing syntactically wrong with that. That's a valid division statement in its form, but it has no meaning. And so when the computer encounters that, it creates a runtime error and halts execution. Runtime errors are often also referred to as exceptions. The last kind of error is a semantic error, and this is also called a logic error. And it refers to errors in the program that did not interrupt execution. Instead, they refer to elements of a program that create improper results. What this means is that, suppose you're trying to add two numbers together, and so you create these numbers as variables x and y, and then you type in the result and call it sum is equal to x plus x. And so what you've actually done is written a program that returns 2x rather than x plus y. So when you run this program, you'll get incorrect results. This is a bug in your code, and it's a semantic error. It's where the program is technically correct. It runs. There's no flaw in the language, and you're not trying to do anything illegal or or that the computer can't understand, but the logic of the program is wrong. It doesn't do what it's supposed to do. Now, debugging semantic errors is the trickiest part of computer programming. It's oftentimes when, especially as you get into larger programs that have hundreds or thousands or millions of lines of code, finding a semantic error can take hours and hours of searching. Fortunately for this course, most of our programs are going to be much shorter than that and should be fairly easy to figure out. Later on in the semester, we'll also talk about some tricks for debugging that can help speed the process along and make it much easier. Debugging is the most important skill you can have as a computer scientist. It's also a very frustrating process. The thing that separates the great computer programmers from the average computer programmers is their ability to quickly determine what the source of a bug is and correct it. When we talk about debugging, we mean that you need to be able to search through your program, identify possible problems, and fix them. Now, it's important to note that debugging is experimental when done. Often when you run a program, you'll get some unexpected result or some error that you don't count on, and you'll be able to identify 4 or 5 different possible causes for it. It's important that you follow some experimental process when you're trying to resolve these and only fix one problem at a time so that you can identify the specific case that created the issue and that you don't introduce additional issues as you resolve old ones. To step back to our discussion of languages, we've talked a little bit now about the Python programming language, and I want to contrast that with how it differs from languages that we speak. A spoken language is considered a natural language. English is an example of this. And natural languages evolve and grow naturally. They don't have a specific process that's used to create or refine them. They're not designed. Formal languages, however, are designed for specific purposes. Most programming languages follow a very strict syntax and are designed to help solve a specific class of problems. Some languages, like Python, are more general in their purpose, but they're just as specific. Now, all languages have syntax, but formal languages are much stricter in their syntax. In English, if you're reading a book and you encounter a sentence that has a comma instead of a period at the end, you can still probably understand what that means. You can still probably get the gist of the story. Whereas in a computer program, the rules for syntax are strict, and a single misplaced comma or semicolon or some other symbol can dramatically alter what a program does. And so these rules are enforced much more strictly and intensely. Syntax is made up of tokens and structure, a token being a word and a structure being a set of rules for describing a sentence or a statement. Determining the structure of a sentence is called parsing. Once a sentence has been parsed, you can explore the semantics or meaning of a sentence. There are many differences between formal languages and natural languages, but the big ones to keep in mind are ambiguity, redundancy, and literalness are all important to formal languages. One of the things that you'll find is that when we talk about ambiguity in spoken languages, natural languages, it's possible to have a sentence that has multiple meanings or a phrase that has multiple meanings. And I use the example here of a dog eating chicken. Now, when you think of a dog eating chicken, there's probably one of two things. And the most common is probably, you can imagine, a dog with a bowl of food, and inside that bowl of food is some fried chicken or some other kind of chicken, and the dog is eating it. But an alternate way to think about a dog eating chicken is a giant chicken with fangs and teeth chasing this pack of poodles across the landscape and chowing down on them. And so these are two different examples of a dog eating chicken. And this ambiguity in English, we can generally resolve. We can generally say that one of these things is much more likely to be what's meant than the other. But in formal languages, such ambiguity isn't allowed. The other big thing I want to make a note of is literalness. And that is when we, in English or in other natural languages, we are often not literal when we speak. we might say, for example, that you're so hungry you could eat a horse. Well, a horse is a tremendous amount. No human could actually eat an entire horse. Um, but we say that to emphasize our point, to say something as a turn of phrase. In computer programming, languages are perfectly literal all the time, and you have to understand that and respect that if you want to be successful in describing your program or your process. Programming languages are also very dense. They're not always structured top to bottom, left to right, as you might expect. You might try and imagine that reading a computer program might be like reading a page in a book. And there are many parallels here. And most of the time, you do actually read top to bottom and left to right. But not always. Sometimes it changes up, and we'll talk about specific cases of that as we go through the language. You'll also find that programming languages are much more dense. You don't use extra words or extra sentences unless you absolutely need to. Now we're going to work through a simple exercise here in a minute. We're going to open up Python on the computer, and at the prompt type in "Hello World." This will result in some output. In fact, it'll result in the what's called the string that you typed into the print statement. And you can see the syntax for this statement on the video. We'll go through this again in a moment. Now this is using the Python prompt, and we'd spoken earlier about how this isn't generally how we want to write or programs, partially because we can't write complex programs, and partially because we can't save our programs when we and rerun them later. So we'll open up idle, and if you go into idle and click new, you'll open up a new file window, and you can replicate your program there. You can then save the file as helloworld.py. Now sometimes you want to include text in your programs that you don't want to execute. By beginning a line with a hashtag, nothing else on that line will run. Modify your Hello World program by adding your name to the beginning of it so that it looks something like what's on the screen. When you run the program, you'll see that you just get the Hello World statement. You don't see what's in what's called the comment. Now the last thing I want to talk about in this video before we work through this exercise is the homework layout. Whenever you write a program for this class, I want it to have 3 lines of comments at the very top. It's the very first 3 lines. The first line should be the letters HW and then the homework number. So the numbering system for this class follows section 1, chapter 1, homework 1, and we would call that homework 1.1.2, or for the comment, simply homework 112. Then on the second line, include your name, and on the third line, your date. It may also be helpful to you to include a comment that includes a description of the program, so that when you come back and refer to your programs later, you have a sense for what you were trying to accomplish. And then below these comments, you can place your code. Now, if you open up idle, you'll see that you can type in print and then hello world. When we run this, we see the text appear. Now, if we want to write this program as write this into a program that we can save and use later, we can go to File and click New Menu, or sorry, go to the File menu and click New File, and then we can write our program in here. 112. And my name is Jacob Belmore. And I can say then print hello world. Now you may have noticed some things about this statement. First of all, the word print has to be lowercase. If you try and capitalize the first letter, you'll actually encounter an error. So if we save this, we can save this as 112.py. And if we try and run it, then we get an error. It says print is not defined. It doesn't know what the word print means when we use a capital P. But if we go back to our program and we use a lowercase p and rerun it, then we'll see that our text occurs. Now this is the basic format for writing programs, and it's generally how you'll write your computer programs for this class and elsewhere, is you'll start off by opening up the program file and editing it and then running it against the command line and making sure that the program you get is the program you want. Now before we finish, I want to talk a little bit more about the print function that we're using here. In order to use the print function, you need the keyword print in all lowercase, followed by a set of parentheses. And inside the parentheses, you have what's called an argument list. In the simplest case, you would simply include a piece of text between quotation marks, and this would appear as output. You can also use this with multiple pieces of text and separated by a comma. So if I include here that my name is Jacob, what we'll see is that the comma prints out both statements separated by a space. Now if we forget this comma, if we don't include it and we simply have the two strings side by side, Python won't know what to do with that, and we'll get some sort of error, or it will concatenate them.